All right, hello everyone, and welcome to our last set of notes for our stoichiometry unit. And we are going to be discussing what are known as limiting reactants. And before we get to your exact notes, I do want to give you an analogy. All right, and we're going to talk about, instead of a chemical reaction, we're going to talk about sandwiches. Okay, and when we make our sandwich, all right, Mrs. O'Donoghue's sandwich is a little sad. So this sandwich is just going to have 2 slices of bread, okay, and 1 slice of turkey. That is your job to make this particular sandwich. The supplies I'm going to give you are this. I'm going to give you 10 slices of bread, and I'm going to give you 10 slices of turkey. I want to know how many sandwiches you can make. All right. Now, as you look at this, you should be telling me, okay, well, I can make 5 sandwiches. Okay. And you can make 5 sandwiches because once you've made 5 sandwiches, your bread runs out. Because remember, you need 2 slices of bread for each of my sad little sandwiches. So once you make 5 sandwiches, the bread runs out. So it's actually your bread that limits how many sandwiches you can have. So we would call this, if this was a chemical reaction, a limiting reactant. Okay, the bread runs out, therefore I cannot make any more sandwiches. If it was just up to the turkey, you could actually make 10 sandwiches, right? Because each sandwich only needs 1 slice of turkey. So I could have made 10. And actually, once I've made my 5 sandwiches, I have turkey left over. So this turkey is actually in excess. All right, so when you've seen that in our previous problems where you have excess of something, that means you have it left over, okay? It could actually make more. All right, so let's see this in action with some chemistry problems. So here we are into your notes. All right, oftentimes you have a specific amount of each reactant, and that's how you're going to know it's a limiting reactant problem. You're going to have a specific amount of each reactant, okay? In this case, one reactant may run out before the other, just like our bread did. This reactant is called our limiting reactant. All right, solving limiting reactant problems is really just a stoichiometry problem, but you have to do an extra problem at the end. So as always, we're going to start out balancing our equation. That never ends. We're going to do 2 stoichiometry problems, 1 for each reactant. Okay, then the reactant that gives us the smaller amount of product is our limiting, just like our bread gave us the smaller number of sandwiches. Let's go on ahead and look at an example. All right, what mass of sodium chloride is formed when 25.1 grams of sodium reacts with 35.2 grams of chlorine? Well, first step in any stoichiometry problem always is to write the balanced equation. So I have sodium reacting with chlorine, remembering that chlorine is diatomic. I am producing sodium chloride, +1 - 1. All right, I need to balance it, and now I'm good. Okay. All right. So now you have 2 numbers in this problem. You have 25 grams of sodium and you have 35 grams, and I'm just going to write this in so we can see it, of chlorine. So right there, I have an amount of each reactant. I need to do 2-factor label problems. All right. So I'm going to start my first one, 25.1 grams of sodium, and I'm looking for, okay, what mass of sodium chloride. So I'm looking for grams of NaCl. Okay, in 1 mole of sodium, I have a molar mass of 23.0 grams. Then for my balanced equation, 2 moles of sodium. All right, for 2 moles of NaCl, even though these numbers will divide out, you have to leave those in, all right, to show the relationship. 1 mole of NaCl has a molar mass of 58.5 grams. All right, when I put that in, I find that I can make 63.8 grams of sodium chloride from that sodium. All right, but we also are dealing with a specific amount of your other reactant, chlorine. So I have 35.2 grams of Cl2, 1 mole of Cl2 molar mass of 71.0 because a single chlorine is 35.5. All right, balanced equation. I have 1 mole of Cl2 for every 2 moles of NaCl. And then finally changing it to grams. All right, you're going to punch that in your calculator and you'll find that this gives 58.0 grams of NaCl. All right, well now it's time for you to actually answer this question. You've done a lot of work here for me, all right, but you actually haven't answered it because right now you're giving me 2 answers. And you have to tell me with these 2 reactants and these specific amounts, how much sodium chloride could I possibly produce? You're going to choose the smaller of the 2 product numbers, which is 58.0 grams. Because once I've made 58.0 grams, my chlorine runs out. That chlorine is your limiting reactant, which would mean my sodium here is my reactant in excess. All right, so again, we did this 2 stoichiometry problems. We then chose the one that produced the smallest amount of product because once this is produced, chlorine runs out. If you don't have any more chlorine, you have no more reaction. All right, great. Let's go on ahead and do our next example. Okay. In a lab, a student produced 10.4 grams of ammonia from the reaction of 5.5 grams of hydrogen and 10.2 grams of nitrogen. What was her percent yield? All right, well, as always, we are going to start out with our balanced equation. All right, the student produced 10 grams of ammonia, so we are making ammonia, right? Remembering ammonia is NH3, that's an important one to remember. And we're making that from hydrogen and nitrogen. Again, remembering that both of those are diatomic. All right, so we've done this one a couple different times before. I'm gonna need a 3 here and a 2 here, and then I'm good to go. All right, so now it's time to deal with our numbers. In this case, I've given you 3 different values, so you have to be really careful which numbers you choose. In a lab, a student produced. So this student producing, all right, this is your experimental or your lab value. All right, we're gonna leave that till the end. How did she produce that? Well, she reacted 5.5 grams of hydrogen and 10.2 grams of nitrogen. We want to find out from that combination how much in a perfect world, theoretically, she would have produced. So let's go on ahead and start. I'm going to switch my pencils out here. I have 5.50 grams of H2. I have 10.2 grams of N2. I am going to find out for each of these what mass of ammonia I can produce. Feel free, if you feel comfortable, to pause the video, all right, and try this on your own. Otherwise, just go on ahead along with me. 1 mole of H2 has a molar mass of 2.0 grams. All right, I have 3 moles of H2, again for my balanced equation, for every 2 moles of my NH3. And then in 1 mole of NH3, my molar mass is 17.0 grams. Okay, great. So once I punch this in my calculator, I get about 31.2 grams of ammonia. I'm going to do the same thing now, but with my amount of nitrogen. 1 mole of N2 has a molar mass of 28.0 grams. All right, then I have 1 mole of N2, remember for my balanced equation, for every 2 moles of NH3. And then in 1 mole of NH3, I have 17.0 grams of NH3. All right, punch that in and I get about 12.4 grams. Okay, so it's your job to figure out what the theoretical yield is. Remember, you're going to choose the smaller amount because once you've produced 12.4 grams of ammonia, your nitrogen runs out. If you run out of nitrogen, there is no reaction. All right, so theoretically, this student should have produced 12.4 grams of ammonia. All right. She, in the lab, produced 10.4 grams. So her percent yield is going to be 10.4 divided by what she should have gotten, 12.4, and we're going to multiply that by 100, because remember, that's your lab value. This is your theoretical value. Okay, and that gives you, she did a pretty good job, about 84. Let's actually punch this in to see exactly. So 10.4 divided by 12.4 times 100. Yeah, it gives you about 83, let's say 83.9 if we're being good. All right, about 83.9% as her percent yield. Okay, all right, great. Okay, on the last page of your notes, okay, you have where it reads more limiting reactant practice. Go on ahead, please pause this video and attempt letter A. All right, welcome back. And here we are looking at letter A. Okay. All right, as always, we're going to be starting out with our balanced equation. Always, always. Okay. In a lab, a student reacts 2.5 grams of iron 1 sulfate with 3 grams of sodium hydroxide. The teacher anticipates an 82% yield. What mass of precipitate must the student retrieve to achieve this yield? Well, as I mentioned, first thing, balanced equation. Identifying what your precipitate's going to be, which is going to be your iron 1 hydroxide. You're going to do your 2 factor label problems. All right. You're going to find that 1.75 here is your theoretical yield. Okay. That is what in a perfect world the student should have gotten. The teacher is a little bit more realistic and says that she's just anticipating an 82% yield. So you're going to take 82% of that 1.75. And in order for this student to be successful in this lab, she should get 1.44 grams of iron 1 hydroxide. All right. Certainly feel free to pause this now so you can jot it down just in case you missed anything. All right. Last problem of the notes. Please attempt letter B. All right. And I have too many letters going on. Please write the balanced equation. Please find out what your theoretical yield is and identify the limiting reactant. That last portion, what mass of excess, hold on and I will help you through that one. So pause the video and attempt those problems, please. All right, so here we go. I have 25 grams of ammonium phosphate reacts with 18 grams of copper 2 nitrate. As always, I'm starting out with a balanced equation. This is a precipitate problem, so I identify my precipitate as copper 2 phosphate. I have done my 2 stoichiometry problems, my 2 factor label problems, to determine which amount of product I'm actually going to get. Okay, so what is the theoretical yield? Well, remember, I choose the smaller of the 2 values. So I would, if this was a test or a lab, I would circle that answer because you don't want to leave 2 answers. So that is your theoretical yield. What is your limiting reactant? Well, it's the reactant that gave you that yield. So that is CuNO3 which is our copper 2 nitrate. Our copper 2 nitrate is the one that runs out. Our last problem here, and this is a little bit of a challenge problem. There are different ways of solving this problem. I'm going to go over the one that I like the best, that makes the most sense to me. Okay. What mass of excess reactant should be left over? Now we know ammonium phosphate is our excess. We're going to have some of that left over. All right. So I like to think of it and do the problem like this. I know I am producing 12.2 grams of copper 2 phosphate. So I'm going to start with that. So 12.2 grams of Cu3PO4 2. Okay. And I want to figure out exactly how much ammonium phosphate it took to make that. All right. So I am going to solve over here for grams of NH4,3PO4. All right, so I already have all of these numbers, so it shouldn't take me very long. So 1 mole of Cu3PO42 has a molar mass of 380.5 grams. I am then going to go do my mole to mole. I have 1 mole of my Cu3 PO4 2. And remember, I'm going to ammonium phosphate now. I'm going to my excess. All right, so ammonium phosphate, if I looked at my balanced equation, I have 2 moles there. And I'm going to change that now to grams, and that mass, 1 mole of ammonium phosphate, has a mass of 149.0 grams. Okay, I'm running out of room a little bit, but that's okay. I'm going to go ahead and punch that in my calculator. So 12.2 times 2 times 149 divided by 380.5. Okay. And that's giving me about, I'm just going to move this little gram sign to make this look nicer, 9.55 grams. So it took me 9.55 grams to make, grams of ammonium phosphate to make 12.2 grams of my copper 2 phosphate. All right, well, how much ammonium phosphate did I start with? I started, if you recall, with 25 grams of ammonium phosphate. So I started with my 25 grams. All right, I only used up 9.55 grams of that. Okay, so 25 minus 9.55, which leaves me with about 15.5 grams left over. Okay, so I have 15.5 grams of ammonium phosphate left over. Now, again, there are more than one way to solve this problem. And if you figure out a way that works for you, that's great. But this is the way that makes the most sense to me. I take my theoretical yield, okay, and I just convert that back to my excess. That's how much excess I used. This is how much I had. All right, so this was my started with. I started with this. I used up 9.55 grams. So what do I have left over? 15.5 grams. All right, have a great day, everybody.